Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from differentiability of a function, right? So here we have this problem, that is we have to check the differentiability of this function, that is f of x is equal to e raised to mod of x minus 1 at x is equal to 1, right? So here we have to prove whether this function is differentiable or not at x is equal to 1, right? So in order to prove this problem of differentiability here, what we will do, we'll make use of the concept of left hand derivative and right hand derivative, right? Suppose y is equal to f of x is a function defined on some domain D, right? So here if we take any point, say x is equal to a belonging to the domain of this function, if we have to check whether this function is differentiable at x is equal to a or not, what we do, we find the right hand derivative and left hand derivative, right? And if the right hand derivative exists and it is finite, and left hand derivative also exists and finite, and both the derivatives are equal, then we say that this function is differentiable at x is equal to a belonging to the domain of the function, right? But if the right hand derivative does not exist, or it is not finite, or the left hand derivative does not exist or it is not finite, then we say that the function is not differentiable at that particular point, right? And moreover, if the right hand derivative exists and it is finite, and the left hand derivative also exists and it is finite, but both the limits, actually right hand derivative and left hand derivative are nothing but limits, right? So if the two limits exist and finite but they are not equal, then also we can say that this function or the given function is not differentiable at that particular point, right? So in this given problem, what we will do, we'll first find out the right hand derivative, and we'll see later on that the right hand derivative, it does exist and it is finite, right? And similarly the left hand derivative also exists and it is finite, right? But both the limits are not equal, right? So we conclude that the function is not differentiable at x is equal to 1, right? So let us first find the right hand derivative. So the right hand derivative is defined by the limit, that is limit h tends to 0 f of a plus h minus f of a divided by h, right? So this is the definition of derivative of a function, and here this point a is equal to 1 in this case, right? So here a is equal to 1, so we have limit h tends to 0 f of 1 plus h minus f of 1 divided by h, right? Okay, so now we have to find the value of f of 1 plus h. So here f of x is e raised to mod of x minus 1, so for x we can take 1 plus h, and for f of 1 we can take x is equal to 1, right? So now we can write limit h tends to 0 f of 1 plus h can be written as e raised to mod of 1 plus h minus 1, and f of 1 can be written as e raised to mod of 1 minus 1, right? And divided by h. So now we can simplify it. So this is limit h tends to 0, and this is e raised to mod of h, 1 and 1 get cancelled, and here we have mod of 0 divided by h, right? Now see here we have to now evaluate this limit. Now see this quantity h, it lies between 0 and 1, and h is a positive quantity, but it is a very small quantity, right? So mod of h is simply equal to h, and mod of 0 is equal to 0. So now we can write limit h tends to 0 e raised to h, mod of h is h, minus this is e raised to 0. So we have e raised to 0 is 1, e is the exponential number, and we have 1 over h, right? And now we see that this limit is a famous limit, and it is a known result in limits, and we know that limit h tends to 0 e raised to h minus 1 over h is equal to 1, right? So here we are directly using the result for this limit, and this limit is equal to 1, right? So we see that the right hand derivative of this function at x is equal to 1 is equal to 1, right? So we can also write this 1 is equal to f prime of this x at x is equal to 1 is equal to 1, right? And here we'll write the positive sign, because this positive sign indicates that we are calculating the right hand derivative, right? So in other words, we can also write it as f prime of 1. Here we can write 1 for x, and here we can write the positive sign, so we have 1. So the right hand derivative is equal to 1. Now let us find out the left hand derivative. So now the left hand derivative is defined by the limit h tends to 0 f of a minus h minus f of a divided by minus h, right? And for a we have 1, right? So the left hand derivative is the limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h, right? And now, as we have done in this case, we can find out the value of f of 1 minus h. So we can write e raised to mod of 1 minus h minus 1. For x we can write 1 minus h, and here for f of 1 we can write e raised to mod of 1 minus 1, right? And divided by minus h. So we have limit h tends to 0 and e raised to here 1 and 1 get cancelled, mod of minus h. Here we have e raised to mod of 0 divided by minus h, and e raised to mod of minus h is simply equal to positive h, and mod of 0 is equal to 0, right? So now this is limit h tends to 0, and here we have e raised to h minus e raised to 0 is equal to 1. So here we have 1 divided by minus h, right? Okay, so now see here we have a negative sign, but in the case of right hand derivative we did not have a negative sign here, so we had the positive sign, right? So now we can take this negative sign outside the limit, and we have limit h tends to 0 e raised to h minus 1 over h, right? And now we have seen earlier that this limit is equal to 1, so this is minus 1, right? So the left hand derivative of this function at x is equal to 1 is equal to minus 1. So we can write the left hand derivative as f. Here we can take negative sign, here we have the prime sign, and then we have 1 here, that is equal to minus 1, right? So the left hand derivative is equal to minus 1, and the right hand derivative is equal to plus 1, right? And here we see that both the limits exist, and they are finite, but they are not equal, right? So the right hand derivative is not equal to the left hand derivative, that is 1 is not equal to minus 1. So we conclude that this function is not differentiable at x is equal to 1.